Hi, my name is Vijay Kumar, Department of ECE, Individuals Engineering College. Today we computer organization and architecture. Computer organization and architecture. What is the meaning of computer organization? Computer organization concerned with the structure and behavior of the computer system. The meaning of computer architecture concerned hardware components connected together. This is the difference between computer organization and architecture. And computer organization and architecture, we will discuss the digital computer. Digital digital computer. What is the meaning of computer? It is a electronic device, performs the operation arithmetic and executes the programs. The computer means digital computer. It will depends upon the only binary system. The data only will takes. Computer changes the data in any form of the data. It changes into the binary. Binary means it is zeros and coming to block diagram. Diagram of device put after the device memory. Coming to block diagram of digital computers, there are mainly have PU, memory, one is put device, out device. First of all, coming to CPU. This is the brain of the computer. The brain of computer. In the CPU, with the CPU of CPU, we can perform the arithmetic logic operation, ALU operations, control unit. ALU means arithmetic logic unit. Control unit 2. Next, registers. These are the blocks will be there in the CPU. ALU, C, and registers. What is it? How can we perform ALU means arithmetic logic operations. What are the arithmetic operations? Addition, subtraction, division, multiplication. These are the arithmetic operations. Coming to logical operations, AND, OR, NOT, NAND, NOR. These are the logical operations. Coming to control. Control unit means it transfer the data how it transfer the data in the CPU or in computer. Next, registers. Register means it's a collection of flip-flops. Registers means it's a collection of flip-flops. Memory. Coming to memory block, it has two memories. One is primary memory, another one is secondary memory. Primary memory, the example of it is a temporary memory. Primary memory also we call as temporary memory. The example of primary memory is RAM. Example of primary memory is RAM. ROM, these are the example of primary memory. Only temporary storage purpose only we can use the primary memory. Next, secondary memory. Secondary memory, it is a storage device. It is a permanent storage device. These devices. These examples are hard disk, pen drives. These are the example of secondary memory. Next, these two blocks are completed, CPU and memory. Next, coming to input device and output device. Input device means we are giving to data using of input device only to the system or computer. The information transferring from one input device to computer. We are sending these examples are mouse, keyboard and scanners. Output device. What is the meaning of output device? We will get the data from the computer to the output device. The output device here is PC, next printer. These are the output devices examples. This is the basic block diagram of digital computer. Next, we will discuss the next is the registers. Registers. Register. Registers means it's a I already told it's a collection of flip-flops. Registers means collection of flip-flops. What is the meaning of flip-flop? Flip-flop means it's a 1-bit storage device. A 1-bit storage device. 1-bit storage device. What is the meaning of register? Register meaning is collection of flip-flop. Flip-flop means it's a storage 1-bit storage device. Here in the CPU, we are transferring the data from one register to another register. How it will transfer? Just now, register we can denote it with the rectangular register is shape of rectangular shape. It is a rectangular shape. Rectangular shape. Next, the rectangular shape. Next, the denotion is 5, 4. The individual bit denotion. Well, bit. Next, in this one, we can denote with directly like this. Means 0 to 15. This means this is the 16-bit length register. Bit length. Here we are denoting only register of low bit value and register of high bit value we can denote it. of low bit value and register at high bit value. Here what is the low bit value? 0. High bit value is 50. Next, if we are dividing from 0 to 8 is one register and 9 to 15 is the another register. That means here one register will be there. The this data is stored in the one register and this data is stored in the another register. This is the denotion of the registers. What are the denotion? It is a rectangular shape and we can individually representation will be there in the registers. Next, if only one register will be there, the bit length is depending upon the bit length, we can denoted with here like this. Next, if the bit length is 16 only, but we are denoting in the different registers, that means 0 to 15. That means here we can divide into two parts. One is 0 to 8, another one is 9 to 15. This is the registers denotion. Next, how can we transfer the data from one register to another register? The transfer line. The transfer. The transfer. Here the data is in A register. Is in A register, but I need to send the data in the B register. How it can transfer? With the using of arrow symbol, we can send the data from one register to another register. This is the one register and this is the second register. Okay. Next, register examples. Examples are register denotion. Always register caps. We can denote it with caps letter R1, RA, RB. These are the register. Next, arrow mark. This is the transformation of data from one register to another register. Next, bus and memory transfer. And transfer. The another topic, bus and memory transfer. Bus, why we are using the first we will discuss bus transfer. Why we introduced the bus transfer the computers? Why we introduced the bus transfer in the computers? Because from one register to another register we are sending the data, but on that same time when we are in only in the A register data, I need to send so many registers. That means thousands of registers. But it is not possible one by one to send. So that's why we introduced the bus. In the bus, we can send the information from one register to another register at a time. Thousands of registers or hundreds of registers. Okay. That means first information is in A, then we will send the data to bus. From there we can send the which register needs the data from A, that we can send the data directly. From bus to we can send the data B, R1, R2. At a time we can send the data. For this one we can take the one example. For that one, I am taking 4 multiplexers. Next, 4 register. 4 register. Multiplexer means, generally multiplexer means 2 power n inputs, single output. That is the multiplexer. That means here I am taking the 4 next for selection lines. How many selection lines? The 4 inputs are there, 2 selection lines. That means S not S. Here also the register also has content is 4 bits data only. This is the R3, R1, R0, 3. Okay. Next, from this one, we are sending the every bit of 0 data. We are connecting the mux1, the mux1, the mux2, the mux3, the mux. The every bit of 0, every register bit of data we are connecting to the mux1. Same as it is first bit. One data is there, right? In every register, 1 will be connected to the mux2. In every bit, every register, second bit, 2 bit is connected to the third mux3. In every register, third bit will connect to the mux4. Mux4. After that, the mux is depending upon the selection line. The 0, 0, 0, 1. Because 2 selection line means how many possibilities are there? 4 possible. If the 0, 0 means selection line 0, 0 means S not S1, the out is S not S1, the selection line S not 0, 0. 0, 0 means here what will mux1 will enable. Mux1 will be enable. On that time, in every register, 0 bit will be passing through the mux1, this output. That means here register R0, R0. Next R1, next R2, next R3, like this. This is the bus transfer. Next, memory transfer. Next, in the memory transfer, we have 2 types of operations are there. One is operation is coming to here in the memory block. More thing, hierarchy. We have 4 types of memories are there. First one is main memory. Auxiliary memory. Associate memory. Cache memory. The types of auxiliary cache. Main memory means already discussed. The temporary memory. Example is RAM. Next, auxiliary memory. Auxiliary memory means it is a permanent storage. We can use the magnetic tape, magnetic disk. Okay. The temporary storage purpose, we can use this memory. Next, cache memory. Cache memory, why we used the cache memory mean repeated instruction. If the any instruction is repeated, then we can use the cache memory. The speed of the cache memory is very high, and main memory is the average. The speed average. Auxiliary memory is very. The topic of computer organization. Next, discuss two topics.